Noisy, dirty, sluggish, smoky. These criticisms and more used to be the popular conception of the diesel engine. Times have changed. Soaring fuel prices made people become aware of the benefits of the diesel. Economy, reliability, pulling power, and so on. Rover designers could see a whole new potential market opening up for diesel engine cars if they could achieve certain requirements. Quietness, performance, and weight reduction were among design yardsticks to be met if diesels were to be a success in the car market. As a result, new techniques such as turbocharging, intercooling, two-stage fuel injection, and greater use of aluminium alloys for cylinder heads, for example, have enabled the designers to meet the challenge and assure a steadily increased demand for the diesel today. One major problem remained. The growing use of the diesel has made everyone aware of its potential to pollute the atmosphere. So much more stringent regulations are being introduced progressively over the next few years to ensure these emissions are kept to a minimum. This challenge was quickly taken up by the Rover engineers. They started with a clean sheet of paper to design a new diesel engine, and as a result of many years of development and hundreds of thousands of test miles later comes the launch of a brand new 2-litre engine in the Rover 600, the L series, the first of a new generation of diesels from Rover. The turbocharged and intercooled L series is an engine that we feel justifiably proud of. It has performance, 105 PS in fact, which gives a 0 to 60 acceleration time of 11 seconds and a top speed of 114 miles per hour, figures that will put many equivalent-sized petrol engine cars to shame. And if you had the chance to drive the car, you'd be amazed by its smoothness and quietness too. Incidentally, fuel consumption at a steady 56 miles per hour has been measured at a remarkable 67 miles per gallon. Not bad for a high-performance 2-litre engine. The potential problem we mentioned earlier, emissions, has been reduced to an absolute minimum. The L-Series engine meets all emission regulations, both present and for the foreseeable future. And as you'll see in a few moments, we've entered a whole new diesel engine world by introducing total electronic control and an oxidation catalyst to bring this about. For example, if you haven't heard of the term fly-by-wire before, then you have now. The accelerator pedal is no longer connected to the fuel injection pump by a cable or linkage. Its movement is registered electronically, and hence the term fly-by-wire. It's a term you'll hear a lot more about in the future. A potentiometer on the pedal senses the driver's foot movement and signals the ECU accordingly. The ECU is located in the passenger footwell. It analyzes this signal together with all the other information it receives and then decides what changes to make to the fueling system. So now let's look at the engine's features. It has a cast iron block to give the necessary strength and rigidity, but alloys used for the sump and cylinder head to save weight. We'll look at the cylinder head with its overhead camshaft in more detail later, and you'll be interested to know it has hydraulic tappets. Here you can see the single external poly V-belt with its fully automatic tensioner controlled by a spring. You'll quickly note that the belt drives the air conditioning compressor, power steering pump and alternator, but it does more than that. A further look at the alternator shows you that the brake system vacuum pump is integral with it, so it's being driven by the drive belt too. And when you examine the power steering pump more closely, you'll see that the water pump is located on it and therefore driven by it. This two-part cover contains the camshaft drive belt, and with the cover off, you can see the drive gear to the single overhead camshaft. We'll have a look at it later in the program. This is the oil pump housing. The pump is driven by the front of the crankshaft. Number 1 cylinder is at this end of the engine, and when timing pin 18G1523 is fitted, numbers 1 and 4 pistons are at top dead center. It's worth noting that all timing procedures are made at TDC with number 1 firing. As we said before, the cylinder block is cast iron, and the alloy sump incorporates a location for a torque rod. With the sump off, you can see the conventional layout. The 5-main bearing crankshaft has its end float controlled by these thrust washers in the center main bearing. On this side of the engine, you can see the oil filter, easily accessible from under the car, the EGR valve and the turbocharger with its wastegate. Just behind the turbo is a depression limiting valve. It's an important part of the engine breathing system, controlling the depression in the crankcase. If you remove it for any reason, you must refit it the correct way around. The pipe marked F must connect to the turbo duct and the pipe marked K to the breather hose. If you get it wrong, the excessive crankcase pressure then created will undoubtedly force oil out past the oil seals. At the flywheel end of the engine, you'll find another belt cover and another innovative design feature. With the cover off, you can see that a gear on the flywheel end of the camshaft is driving a second gear which turns the fuel injection pump. This clever bit of engineering means that you can now remove the camshaft drive belt without disturbing the pump timing. Incidentally, the camshaft and injection pump drive belts must both be renewed together when called for at the appropriate service intervals. Moving further round, this alloy housing is the oil cooler. You can see the oil pipe connections underneath it. The oil is cooled by coolant passing around it inside the housing. And directly above it is the fuel injection pump. It is identified as an EDC pump, standing for Electronic Diesel Control. If you look closely at the pump mounting points on the engine backplate, you'll notice they are not slotted, so it's not possible to adjust the pump timing on this engine. It's been preset by the manufacturer, and any adjustment needed during running is done by the fuel system ECU. At this stage, we must mention one very important service point, and we'll probably say it again before the program finishes, because it's vital to remember. It concerns this lock bolt. If you ever have to remove the pump, you must first slacken the bolt, take out the thick washer, and tighten the bolt to 31 Newton meters to secure the pump drive shaft from turning. If the shaft is left to turn freely, you'll have no means of retiming the pump. And don't forget to refit the washer during the rebuild before attempting to turn the engine over. The injectors have a two-stage operation for quietness and emission control. They cannot be pressure tested or adjusted and must be returned to the manufacturer for servicing. If you look closely at number 1 injector, you'll see that it's longer than the others and has an electrical connection. It contains a needle lift sensor which registers the instant the needle starts to lift for injection. Just one of the many sensors signaling information to the ECU. Before we look at the fuel system in more detail and some of the engine servicing procedures, a few words about the air intake system. This diagram shows the passage of the air. Air is drawn in through the air cleaner to the turbo, which forces it through the intercooler and on to the inlet manifold. Between the air cleaner and the turbo, you can see the breathing system connection from the cam cover and the EGR valve on the exhaust manifold with its connecting pipe to the inlet. Now fueling. A sophisticated electronic control system has been designed to ensure that the correct amount of fuel is supplied to the engine under all conditions: hot and cold starting, light load, full throttle, hot, ambient temperatures and so on. About a dozen sensors supply all the necessary information to the ECU. It analyzes this information and decides how much fuel to inject. We have already mentioned one source of information, the injector needle lift sensor fitted to number 1 injector. It signals the ECU the precise moment the injector starts to open. And another source we mentioned earlier is the potentiometer on the accelerator pedal. The information it provides ensures that the fuel injection pump does not blindly feed the amount of fuel the driver tells it to, but instead, having signaled the pedal information to the ECU, the fueling decision is made electronically after analysis of all the other sensor information. We've identified 2 sensors so far. Let's spot some more. This sensor in the inlet manifold provides air temperature information, and this one in the cylinder head gives coolant temperature. Then there is an engine speed sensor in the flywheel, this pressure sensor on the bulkhead to signal turbo boost pressure, and a road speed sensor in the gearbox. Switches on the brake pedal signal when braking is taking place. Two sensors you can't see are inside the injection pump. One signals fuel temperature and the other the quantity of fuel being injected. To illustrate how the information provided by these sensors affects the fuel supply, we'll look at one of them in more detail, the injector needle lift sensor. The sensor is located in the injector where it can identify the instant the needle starts to open. It signals this information to the ECU, which is continuously receiving other engine and fuel data. The ECU analyzes all the signals and decides whether the injector opening time is correct for the conditions at that moment. If it isn't, it instructs a solenoid valve at the base of the injection pump to move. The solenoid is connected mechanically to the pump advance retard mechanism, and so the injection time will be advanced or retarded when the ECU says so. The changed injection time will be sensed by the injector lift sensor to signal the ECU again, and thus continuous monitoring is made. Incidentally, don't be alarmed if you hear a slight buzzing sound like this from the injection pump when the ignition switched on. It's just the solenoid valve doing its job. By the way, if a needle lift sensor should fail, the vehicle will enter a limp home mode with reduced performance and lack of throttle response. Other functions of the ECU are to control the glow plug system via this relay near the battery, and the EGR valve via this EGR modulator located on the bulkhead. An air flow meter is fitted on the air cleaner outlet hose. It contains a hot film sensor which measures the mass of air passing, which enables the ECU to signal the EGR valve operation accordingly. So, as you can see, the L-Series engine has a very precise engine fueling system, and you'll find more information about it in your workbook. We haven't yet mentioned how power gets to the ECU. It's supplied via the ignition switch and the main relay located on the bulkhead behind this fuse box. Right by the main relay is the inverter relay, part of the air conditioning electrics. In the last part of this program, we'll look at some servicing operations. First, the camshaft drive belt. With the cover removed, you can see the camshaft drive gear at the top. On the right is an idler roller, and on the left, the spring-loaded belt tensioner. When this mark on the camshaft gear aligns with the pointer on the casing, the camshaft is set at top dead center, with number 1 firing. If you are removing the belt, first turn the crankshaft until the flywheel timing pin 18G1523 can be fitted, and check that the camshaft timing marks align. First slacken the tensioner roller fixing, then fit the new tool 18G1719 into the back of the tensioner through the hole in the casing, and turn the nut to retract the spring and release the belt tension. The belt can now be eased off the camshaft gear if, for example, you want to change the oil seal behind it or remove the cylinder head. Incidentally, you will have noticed that the cover is in 2 halves. You don't have to take off the bottom half if you only want to get to the camshaft gear area, and this plug in the front gives you access to release the tensioner roller. If you remove or tamper with the camshaft gear for any reason, you must use a new securing bolt when you refit it. Tighten the bolt to the correct torque while restraining the gear with existing tool 18G1521. Never use the belt to hold the gear. When you are ready to fit the belt, do it like this. First check that the flywheel timing pin is still in position and the camshaft gear timing marks align, before carefully easing the belt over the gear. Keep it as taut as possible on the drive side. Then release the tensioner retracting tool to apply tension to the belt and temporarily nip up the tensioner roller fixing. Remove the flywheel timing pin, turn the crankshaft 2 full turns clockwise and refit the pin. Check that the camshaft timing marks align. Slacken the tensioner roller fixing and allow the tensioner to react. Then retighten it to the correct torque. The belt has now been correctly tensioned and the other components can be refitted. Now let's look at the fuel injection pump drive belt. To remove it, you must be very careful not to disturb the pump timing, so do it like this. First, fit the flywheel timing pin to position the engine at TDC number 1. Then you need a new timing pin, 18G1717. Fit it through this hole in the injection pump gear. Next, hold the camshaft with 18G1521 and slacken these 4 securing bolts. You will see that the 4 bolt holes are elongated for adjustment purposes. You can now slacken the tensioner and remove the belt. If you need to change the camshaft seal, take off the gear to gain access after removing the hub securing bolt. But just like the camshaft front gear, you must use a new bolt when you refit it. Make sure the bolt is tightened to the correct torque. To fit the belt, leave the 4 bolts loose enough for the gear to rotate within the slots. Fit the belt and tension it using an angular torque gauge set to the specified torque, then tighten the 4 gear securing bolts. Remove the timing pins from the flywheel and the injection pump. Then turn the crankshaft 2 complete turns and refit the flywheel timing pin. Reset the belt tension and torque tighten the fixing. Now check the injection pump timing by refitting the pump timing pin. If the pin won't fit, slacken the 4 camshaft gear securing bolts and rotate the gear on its adjustment slots until the timing pin will fit. Never attempt to move the pump gear on its shaft. You will affect the pump timing. To remove the pump, fit the flywheel timing pin to position the engine at TDC, then fit the pump timing pin 18G1717. Next, you must lock the pump drive shaft by removing this washer on the lock bolt, as we showed you before. Then tighten the bolt to the specified torque. The bolt is now holding the pump shaft in the TDC position for number 1 cylinder, and as we said, this is essential if you're going to refit the same pump because there is no way of timing it if the shaft has not been locked. Remove the drive belt as we described before, then leave the pump timing pin in place while you remove the gear nut with its special washer. Use existing tool 18G1512B to remove the gear. All that remains is to disconnect the fuel pipes and electrical connections to the pump before removing the securing bolts and lifting it clear. Make sure no dirt can enter the fuel pipes. Before fitting the pump, check that the lock bolt is tightly in position without its washer. Then run the gear securing nut up its threads to make sure there is no binding. Check that the flywheel timing pin is correctly located and slacken the 4 camshaft gear securing bolts. Now locate the pump and secure it to the back plate and mounting brackets. It's important to follow a special tightening sequence which you'll find in the workshop manual to avoid placing any stress on the pump shaft and components. Connect the fuel pipes and electrical connections. Fit the pump drive gear on its shaft and position it using the timing pin 18G1717. Use tool 18G1771 to hold the gear and tighten the nut to the correct torque. Only now can you slacken the pump lock bolt and refit its special washer, tightening the bolt to its specified torque. You can now fit and tension the drive belt as we described before. After you've done that, don't forget to turn the engine over a couple of times. Refit the flywheel timing pin and check that the pump timing pin locates correctly through the gear. Now we'll look at the cylinder head. As we said earlier, it's aluminium alloy and contains the camshaft and hydraulic tappets, so no tappet adjustment is required. Once the camshaft and the fuel injection pump drive belts and their gears have been detached, the head can be removed as an assembly, or the camshaft removed to gain access to the hydraulic tappets in situ. If you rest the head face down, make sure it's raised on wooden blocks like this, so as not to damage the protruding valves, heater plugs and injectors. By taking off the camshaft cover, you can see the camshaft bearings ladder, secured by 10 screws. Release the screws progressively, about 2 turns each. On an engine that's been in service, sealant will cause the ladder to stick to the cylinder head, so lugs are being cast into the ladder to allow you to carefully prise it up and break the sealant bead. Then finally remove the screws and lift off the ladder. Incidentally, always handle the ladder with care. It's line bored with the cylinder head, so if it's damaged, they'll both have to be replaced. You can now remove the camshaft to gain access to the hydraulic tappets. Be very careful when withdrawing the tappets. Use a magnet if they're tight. Never use pliers. Don't scratch or damage the sliding surfaces of the tappets or their bores in the cylinder head. Retain the tappets in their fitted order for reassembly in the same bore and lay them down open face up to prevent oil loss. Don't squeeze them together. The oil would come out and air would be drawn in to give an excessive clearance when refitted. 3 thicknesses of cylinder head gasket are used to allow for variations in piston protrusion during assembly. They're identified by 1, 2 or 3 holes in the gasket like this. The 1-hole gasket is the thinnest. If you are carrying out service work which does not involve renewing the pistons, connecting rods or crankshaft, then you can replace the gasket with a new one of the same thickness. Incidentally, you can see the identification holes when the cylinder head is fitted. If you have renewed the crank, conrods or pistons, then you must check the piston protrusion. Measure the stand proud at the front and rear of each piston. Then select a gasket to match the greatest stand proud figure. You'll find gasket thickness information in the workshop manual. The camshaft can be installed before or after refitting the cylinder head, but in either case you must make sure it is positioned so that when it's pulled down, the valves will not foul the pistons. Turn it until number 1 cylinder tappets are on the heel of both cams. In this position, the roll pin at the drive gear end of the camshaft will be at 2 o'clock. Carefully apply a thin bead of anaerobic sealant to the ladder mating face, making sure it can't get onto the bearing surfaces. Fit the securing screws and tighten them progressively, in the specified sequence and to the correct torque. Before refitting the head, check that the flywheel timing pin is fitted and make sure the bolt holes in the block are clean and dry. Fit the cylinder head gasket dry and carefully lower the head into position. Before tightening the head down, temporarily fit the camshaft drive gear to check that the timing marks align. The bolt tightening procedure is very important if you are to avoid problems later. First, check for bolt stretch by measuring its length and compare with the specified figure. If any bolt has stretched, they must all be renewed. Lubricate each bolt thread and the underside of the bolt head before fitting it, but don't lubricate the underside of the washers. Each washer has dimples on its underside to prevent it turning when its bolt is being tightened. Tighten the bolts in the specified sequence and in 4 separate stages after first nipping them up. First, tighten them all to 30 Newton meters and secondly to 65 Newton meters. Then you must tighten them in the same sequence by 90 degrees and finally by a further 90 degrees. Before we finish this program on the L-Series diesel, we must mention fault diagnosis. As you've seen, the engine has a very advanced electronic system. This warning light on the instrument panel will flash a warning to the driver if something's not quite right, and then it's over to you. The test book is an essential piece of diagnostic equipment for the system and will connect into a multiplug in the normal manner. That completes our video training program introducing the exciting new L-Series. An engine that's been designed not only to please the customer, obviously that's the prime objective, but which has also received careful consideration in its design and installation for you, the technician, who will have to look after it. Good luck.